Hello, this video will help you understand problem number 15 in chapter 7. The diagram on this one's going to be a little different. It's not really a collision problem, it's more of an impulse problem. So I'm going to draw a golf ball. And the golf ball is being hit by, I think it just says a club. Let's see. Yeah, it just says a club. So what you draw on this is up to you, but that's my golf ball getting hit by golf club. I'm saying going to the right is positive, which means the velocity here will be positive. The velocity we have for the golf ball is the final velocity technically, and it's a positive 45 meters per second, and the mass of the ball is 0.045 kilograms. Now it does say that the golf ball was hit from the tee, and so for those of you who don't know, the tee is the little white thing you put the golf ball on in the ground. So that means, so basically it's like this little thing that holds the golf ball there. It means it was at rest to start with, so you can know that the initial velocity was 0 meters per second. Okay, now we're being told to do two things. For part A, we're told to find the impulse. For part B, we're told to find, whoops, I didn't mean to write equals there. We're told to find out the average force. Okay, so to do part A, we need to first understand, well, what is impulse? Well, impulse is a change of momentum. Okay, in this case, the momentum changed because the velocity changed, not the mass, but we're going to have, oh, whoa. Did I switch the color? I think my pinky hit that. So we had M of the golf ball didn't change, so I can just go and go right mv1 for final velocity minus mv initial. Okay, now that all equals 0, so I can just say, okay, in this case the impulse would be the mass times the final velocity. That's going to give me, the impulse will equal a 0.045 kilograms times a positive 45 meters per second, which will mean the impulse equals a positive 2.025 Newton seconds. And with significant figures, the answer to part A would be a positive 2.0 Newton seconds. That's just the answer to part A. Now to do part B, we're going to use the unrounded number, and we're trying to find the force. You want to know that the impulse will equal the force multiplied by the time. And I just realized I forgot to write the time down. I'm pretty sure they gave it to us in the problem. Yes, they say that the golf club is in contact with the ball for 3.5 times 10 to the negative third seconds. So t equals 3.5 times 10 to negative third seconds. Okay, so that's the t we're going to use there. To find f, I'm just going to have to isolate for f. So f will equal the impulse divided by the time. Go ahead and plug in the unrounded number for impulse. That's going to be positive 2.025 Newton seconds divided by 3.5 times, let me make sure that point's dark enough for you guys, times 10 to the negative third seconds. And we get a value of 500 a positive 587.57 newtons. That means that with significant figures, you'd have a positive 5. Wait, was it 5.87? Hold on, I think I might have made a mistake. Whoops. Let's see. I think I wrote that wrong. 2.025 divided by 3.5. Five, 7. I did switch that. It was supposed to be 578. Dyslexia at its finest. So the answer should be 5.8 times 10 to the second newtons. Okay, so sorry about that delay for the mistake there, but your answer for the force before you round it should be 578, and then you would have to round that to 580, and then with the scientific notation, you'd have with the scientific notation and the sig figs, because you're only supposed to have 2 digits, you'd have 5.8 times 10 to the second newtons. This one's a little different because of the fact that you're dealing with the impulse, so you don't need to draw a collision diagram. You're just drawing the object, the change in momentum. Really, you're noted just by, okay, it's at rest, and this is velocity afterwards, and then you have the time that the force was applied, and then you could figure out, okay, well, what that force is based on the change in momentum. Okay.